Alright, this is my recording for Lab 4 for Intro Robotics with Dr. Conrad. Right now I'm uploading my code from my computer into my Romy robot. As you can see here, I hit upload, it's uploading, and it's coming over to the robot. Completed uploading. Um, the code has completely moved onto my robot. The indication on the green LED tells me that it's complete. I go ahead and I'm unplugging it right now. Heard that sound. I'm lining up my robot to the beginning of that tape measure, to the edge of that tape, and I'm going to hit A. It delays for 2 seconds, then goes and gets started, goes to the end, stops at 36, and then comes back to the beginning. Trial 2, to show we can do it multiple times. I'm ready. Have the code ready to go. I press A, it's off to the end, stops at 36, and then returns. This is the code used for that robot. Here are magic numbers for requirements 4C and 4D in the assignment. Our speed is set to 150 and our time to distance is set to 1850. That would be about 2 seconds-ish. Here's a bunch of variables that we established ahead of time to make sure that we haven't prepared for the rest of our functions. Wheel OD, chassis width, and pulses per revolution are all self-explanatory. They're from the design from the Roby robot. We have one variable called running here, which decides when set to true, it executes our code. At any point, if we hit the stop button, it'll swap this running boolean to false, which tells our code to stop running. We have our state variable that decides what state a robot is going to be in, and we'll get more into that later on, and then a variable initialized for left speed and right speed for both motors. Cool. Our first function is the most important. How do we stop the robot? Basically, we give it a parameter for a button using an enumerator. If we have it empty, it's going to assume button A, and if button A is ever pressed once we start the robot, it will go ahead and stop all of the robot and set motor speed to 0. That works for all 3 buttons, so this is a quick assign function. Our next function is a quick debug function that runs through, if I give it a string with some sort of data type, or sorry, a string with a short message, and a variable, it will print out that message and the data. That way I can quickly just put this function in and find out what's happening in my robot. This is useful just so we weren't hiding like 60 serial print statements in our code. Next is calc pulse. We didn't use this that much, but this was useful in the beginning to figure out roughly how long and what our speed proportions were for our motors to go straight. This takes a certain input distance in centimeters and it tells you how many pulses you need to get to there. Next is battery check. It just prints out the battery voltage to the serial monitor. We run this at the beginning in our setup function. And then finally, this is probably our most complicated function, a ramp to speed, which you set a left motor target and a right motor target, it will slowly accelerate through that target, whether it's higher or lower. All that data is here. All of the parameters that you can pass into this function are defined right below it. So that's very useful. And we used a reference pointer to, instead of reassigning these inside of here, we'll go grab the variable. And so we can assign these. You can just put in left speed, pass in left speed, right speed variables in order to get this function to work. So you almost never end up assigning these first 2 variables, and you assign the targets. That is defined as 5, so you can increase that for a faster jerkier acceleration, or you can just reduce our slow parameter, which will reduce the time in between each step. Either one of these will change your acceleration curve, and these 2 parameters set your speed. In here, our setup is pretty basic. One thing we did add is once the code is ready to execute, it will turn our green LED on, and then it starts waiting for that button A press to get started. Once it gets started, it turns the yellow light on to tell us that it's executing code. That was just some helpful debugging stuff. Once we get into a loop function, as we mentioned at the very beginning, we have our Boolean variable called running. If it's ever set to false, it will go ahead and turn our robot off. It'll spit out the string stopped into a serial monitor if it's connected to the computer, turn the red LED on, and then get stuck in this while loop, so it can never get out because 1 is always able to 1. Our switch case setup is how we control what code executes when. So case 0 is where we start, and we continue through the separate cases using our state variable we mentioned at the very beginning. State is initialized as case 0, so it'll automatically come to here. Here it accelerates to current speed, to that magic speed number we set. Continues on until that acceleration is complete, and a certain time required to get to that distance is also complete. So our time to distance magic number doesn't include our acceleration time, and that's just how we decided to run this lab. Right here is our speed variable for going forward. We have a slightly different one for coming backwards. We found that gave us more consistent results. But we're coming back to case 1. As soon as we have completed that time at our constant speed, it switches to state 1. That moves us down to case 1, where it decelerates to our target 0, 0 for left motor speed and right motor speed, waits for the required 2,000 seconds, then switches our speed variable, which is that magic speed variable initialized up top, and then sets us to state 2. State 2 accelerates to speed. Of course, since speed is now reversed, it's going backwards. We're using different speed proportions here, as I mentioned earlier. Continues to that same time to distance number, and then switches to state 3. State 3, it decelerates to 0, 0, and then stops running completely. Our running state here is set to false, so it runs up into our false running state, and that comes to our stop function. So this let us really quickly iterate, and by doing it this way, we found we could not use delay functions, which meant we could use the same stop if not running stop the robot. Otherwise, we found we had to put in like right before each and every delay to make sure the stop will work. Another problem we ran into was with using the delay function was if it is waiting for that 2,000 seconds and then the button gets pressed, it sometimes wouldn't register the click, which we didn't want. So by setting our code up this way using switch case and avoiding using delay functions, and iterating through our code until we reach a certain condition, it let us take advantage of it helps our code remain more condensed and avoids possible errors.